These are your confidence intervals, notes 3. Today we're going to talk about margin of error, standard error, and the one sample t-interval. Before we do that though, we're going to talk about our one sample z-interval from the last couple days in class. This is the confidence interval we use when we're trying to predict a population mean, and we know the population standard deviation. Now, part of any confidence interval is something called the margin of error. And the margin of error is the stuff after the plus or minus sign in a confidence interval. For the one sample z-interval for means, the stuff after the plus or minus sign is the z star times sigma over the square root of n expression. In this example, that would be your margin of error. I'll abbreviate that MOE. To reduce the margin of error, there are three things that we can do. And the first thing that we can do is we can reduce z star. Now, z star is associated with the confidence level. And if you refer to our chart that we've kind of dealt with earlier, your z star values are basically these numbers here. And to make z star smaller, what you're going to be doing is you're going to be reducing your confidence level. So from left to right, the z star values get bigger as your confidence level gets bigger. And vice versa, if you want to make z star smaller, you can reduce it by reducing the confidence level. However, most of the time we don't want to reduce our confidence level. We want to have a lot of confidence in our answer. So what else can we do? Well, we could reduce sigma, the population standard deviation. Unfortunately, we don't have a lot of control over this. Oftentimes, this is impossible to do. So our final option is to make the margin of error smaller. We're not going to make n smaller because it's in the denominator of a fraction. If we want to make the fraction smaller, we need to make n bigger. So we'll increase n, the sample size, and that's usually the option that we want to do. That's typically the best option. Just like when we worked with standard deviation last chapter, reducing margin of error is impacted by what you do with the sample size. So to reduce the margin of error to half its size, notice we have the square root of n in the denominator. Think about, what do you have to square root to get a 2? Because 2 is in the denominator. Well, you have to square root of 4. So you'd want to multiply the sample size by 4. See if you can figure out what you would do to reduce the margin of error to a fourth of its size and 1/10 of its size. Pause the video and we'll see what you get in just a minute. To reduce the margin of error to a quarter of its size, we're going to multiply n by 16, because when you square root 16 you get 4, and that 16 would be in your denominator. And to reduce the margin of error to 1/10 of its size, we're going to multiply n by 100, because if you square root 100 you get 10. Standard error is related to margin of error, where margin of error is the stuff after the plus or minus sign in a confidence interval. The standard error is the stuff after, in this case, z star. Now, typically in a confidence interval, you're going to have something star. We'll do some problems that have z stars and t stars in them. But it's basically the stuff after the z star that's your standard error. So I'm going to say it's the stuff after the z star, or what we'll learn about later on today, t star. For a one sample z interval, the standard error would be sigma over the square root of n. Now, we've already talked about the fact that a one sample z interval is not terribly practical because a lot of times we don't know what sigma is. And if you actually don't know what sigma is equal to, but you want to make an estimate for mu, we use something called a one sample t interval for means. This is used to predict mu when we don't know sigma. The formula for a one sample t interval for means is x bar plus or minus. We're going to use a different value this time, which I alluded to earlier, t star. And instead of using the population standard deviation, we're going to use the sample standard deviation, S. You can find S on your calculator if you use 1var stats by looking at the SX value on 1var stats. This is your sample standard deviation, and we'll use this in this problem. Now, T star is related to what you see in table C, and it's found in basically the same place that we found our Z star values. I'm going to zoom this in a little bit so you can see a little bit better. We're going to still be referring to our values at the bottom of this page here, so you're still going to see these values like 50, 60, 70, 80%. But you also notice these values along the side. It's highlighted by this thing that says DF. DF stands for something called degrees of freedom. And degrees of freedom is equal to the sample size minus 1. So for T star, you want to look up the degrees of freedom, which equals the sample size minus 1, and the confidence level. And we'll practice this in just a moment. We are going to do a long way problem from the 2004 AP exam. Setting up a problem using a one sample T interval is basically the same thing as setting up a one sample Z interval. The only two differences you're going to find is that the procedure in step 1 is now called a one sample T interval, and the formula in step 3 is slightly different but uses the same idea. Let's take a look at the back side of your worksheet and work through a confidence interval. What I'd like you to do is I'd like you to pause the video for just a moment, read through the problem, and as you read through the problem, take note of the different numbers in the problem. What do the values like 50, 24, and 15 represent in terms of symbols and variables? So take a moment to read through the problem, and then we'll start working through the confidence interval. So a few things you should have noticed. We're talking about a random sample of 50 people, and 50 is going to be your n value in this problem. They also mentioned in the last line that our sample mean reduction and standard deviation are 24 and 15 respectively. So our sample mean x bar is equal to 24, and the standard deviation of the sample is s, and that's your 15. When you set up a confidence interval, what we're going to do is the 4 steps that we talked about the other day. And we're going to start with step 1, where we do the 3 P's. Name the procedure, the parameter, and the population. Because sigma is not provided for us, all we have is s, we're going to be using a one sample T interval in this problem. Secondly, the parameter we're going to measure is mu, and mu always stands for mean. Now in this problem, we're looking for the population mean reduction in cholesterol level. And if you're unsure what the mean is, read through the problem, because you'll notice several times this problem talks about a mean reduction in cholesterol level. That's what we're going to use here, mean reduction in cholesterol level. And then finally, we want to identify the population. The sample in this problem is 50. 50 who? 50 people from the population of people with high cholesterol. So if the sample is 50 people with high cholesterol, the population is all people with high cholesterol. So we include that here as well, for all people with high cholesterol. In step 2, we check our conditions, and the first condition we want to check is we want to see if there's a random sample being taken. It does say in the problem that a random sample has been taken. So I'm basically going to say a random sample of 50 people was taken. Remember that you can also plagiarize and basically say a random sample of 50 people from the population of people with high cholesterol was taken. The second condition is to see if your population is normally distributed. I read through the problem. It doesn't say anything about a population being normally distributed. So the second thing we look for is if a large sample size was taken. And in this problem, it has been. We have a sample size of 50. So I'm just going to say a large sample size was taken. And I'm going to define it as being bigger than 30. So I'm going to say a large sample was taken. In this case, our sample was 50, and that's bigger than 30. Our conditions have been met. We're on to step 3. In step 3, we actually crunch out our confidence interval using our formula. In the problem, x bar is 24. The nice thing about writing it down as I'm working through the problem is I don't have to look it up again. We're supposed to use 95% confidence. T star in this problem is going to come from our table C. So I'm going to drag our little table in here again. We're going to work with 95% confidence, so we're going to go to 95% at the bottom. And for our degrees of freedom, you may remember our sample size is 50. So our degrees of freedom is going to be 50 minus 1, or 49. I'm looking on the chart and I don't see 49 anywhere. I see 50 and then I see 40. So what do? Do you use 50? The basic rule of thumb is this. If 49 is not on here, go smaller and use the next smallest number. So even though 49 is closer to 50, we're kind of going to round down and use the value for 40. Corresponding with 95%, that's going to be 2.021. So we'll write that number down. Our S value is 15. Our N is the square root of 50. Over off to the side, I'm going to write down that the degrees of freedom is equal to n minus 1, or 49. And then you can punch this in your calculator and crunch it out. you may want to just verify that your numbers match up with these values, 19.7 and 28.3. And that's step 3. Finally, in step 4, we interpret our results. So here's where we're going to say that we are, use your confidence level, 95% confident that the mean, and I'm going to define it as mu, the mean reduction in cholesterol level, is between the two values that you came up with in step 5. And those values are 19.7 and 28.3. If there's any units, you'd want to include them here as well. So we'll include that there. And that is your 2004 AP problem solved using 4 steps, and it's your first example of a one sample t interval.